Hey friends, it is Wednesday, October 25th. So what are we doing today? Remember yesterday we did those rules, and the day before we did rules, we did the blue cups, we did the orange cups. Really impressed how you stuck with them. And you took some really hard concepts and you reasoned abstractly, right, without numbers, and then you reasoned quantitatively with numbers. So really proud of your efforts on that. So today we're looking at 3.1.2, and the learning target for today is we will learn how to identify the rule pattern for a rule and state it in words. And our success criteria is, can you find and express regularity in repeated patterns, and can you reason abstractly without numbers and quantitatively with numbers when we describe patterns. So when you come in, we're going to go to our fast bridge warm-up. Remember, our puzzles go blue, green, white, and red. And if you pass those, then we cycle back to blue, green, white, and red. And then we're going to play, this is the way I think we should do it. It's the silent board game. It's fun, but you got to trust the process. And the process in this game is that you have to be quiet, right? So we have to give everybody a chance to think. And then as we cycle through, we don't want talking, because we want you to just listen to what one person's offering and see if that's correct or not, and then see if you can make that make that leap, right, to the next prediction. So that's in 3.1.2. So if we can get to your ebook in here, 3.1.2, we're going to go up to the silent rule, the silent board game. And it's really cool, and I'm not sure exactly like how I would share this with you without actually being here, but I can show you this link to the game, but then you'd have to set up your own problems for it. So here's the silent board game. And the way it works is we give everybody a chance to think, and we try to predict what's going to happen. And then somebody types in a number. Ooh, and it fits. And then somebody else types in a number. That didn't work. What did I type in? 30. Nope, that didn't work. Let me see this one here. I'm going to try 1. Yep, and that one worked. What if I go a half? So, excuse me. 1.5. 2.5. Yeah, okay, that one works. Negative 20. I'm gonna guess here. Yes. Oh, I know why this one didn't work. Got it. So half. I'm gonna guess half. 1.5. 2.5. What if I go 2.5? All right. And do you see what I'm doing here? Because this is what's going to happen in the class. The kids are going to make guesses, and let's say we get one no, we just erase it, and then we just keep moving on. I'm looking at negative half here. Negative 0.5. And this one, I'm going to guess negative 21. Negative 32. Oh, okay. So to figure out why, what I did is I took 3 times this number, and then I added 1 off of that. So I went 3. Let me see if that's right. And then I add 1. And got it. So then we could go to a new game. And this is probably what you get if I share the link, is you just have to select the type of a game. And we're probably going to select linear types and play a random game. And that's the game. Ooh, that's kind of cool. Just y equals, it's just y equals 0 times x plus 1. Yeah, cool. New game. I'm going to take a linear game. I'm going to play a random game. Oh, this will be fun. Then what I'm thinking about doing is between every game that we play, if we can solve it, playing by the rules, then we go play a game of Mafia, and then we come back, play another game by the rules, go back to Mafia, right? I just kind of want to go back and forth that way. I think it'll be a fun day. And I think that's probably all we're going to get to. If we do get done, we're going to go to there's 3 problems on John's Giant Redwoods. And that's in here. And it says this. If we get this far, it's going to say, John found the data in the table below about his favorite redwood tree. He wondered if he could use it to predict the height of the tree at other points of time. Consider this as you analyze the data and answer the questions below. Be ready to share and justify your answers with the class. So 3 years after planting the tree was 17 feet. And 4 years after planting the tree was 21 feet. And 5 years after planting it, it was 25 feet. So the first question, how much did the tree grow each year? And then how tall was the tree 2 years after it was planted? How about 7 years after it was planted? How tall was the tree when it was planted? Estimate the height of the tree 50 years from when it's planted. So that's where we'll start. And then the next problems you can look at 311. We do have this great resource, the eTool, and 312. And those are extensions of the Redwood problems. Redwood problems going to be important because we're going to be seeing this for the rest of the year as we set up linear equations. Okay, so that's what we're doing for today on Wednesday the 25th. We are going to be looking at our Fastbridge game and then our silent board game, pair that with Mafia, and if we get past that, we're going to look at the Redwood problems. Okay, I hope you're having a wonderful Wednesday. I hope you're well, and we hope we see you tomorrow, because we always miss you when you're not here. Oh, and remember, keep your points for the week for participation, because we still have our one-tier treat is if you get 15 points between Tuesday, Wednesday, Thursday, and then your second tier treat if you keep between 12 and 14 points. All right, friends, have a beautiful day. Smell you later.